Corporate finance practice problem using Excel. Bond coupon rate, current yield, and yield to maturity comparison problem. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side, we're going to populate that information into the blue area on the right-hand side. We've got two bond type scenarios, bond A and bond B this time. We're going to be doing some comparisons between the calculations, mainly between the current yield calculation and the rate of return or the yield to maturity calculations. The current yield being a kind of a more quick type of calculation, and the more dependable calculation typically being the yield to maturity. So let's do our calculations up top. We're going to pick up the coupon rate first. That's going to be our basic calculation of the annual interest payment. Annual interest payment being equal to the $100, comparing that to the par value being equal to then the $100. That's going to be our coupon. Coupon rate is this 100. This should be $1,000. Underlining there, font group and underline. We're going to say this equals the 100 divided by the 1,000, making that a percent. Numbers group, making it a percent, 10%. Let's calculate our yield to maturity, the more basic type of calculation, looking at the bond A calculation. This is going to be equal to the annual interest payment, which is going to be the $100. That's basically our return that we would expect to have on a year, compared to the market price, which we're saying this is what we would expect to buy it for, $870. And we're going to go to the font group, underline that. That's going to be the current yield. That's the current yield. That's going to be equal to 100 divided by 870. So now let's calculate the yield to maturity, which is going to take into consideration the longer term perspective, usually a more dependable type of number. We'll do this a couple different ways. So let's see this in terms of a goal-seek type of calculation. Then we'll do the rate formula. Then we'll do our approximation type of calculations. So we're going to, and you may be asked to do this a couple different ways. The new things are our approximation calculations here with regards to this calculation. So first, let's do it by calculating or imagining we're calculating the market price, because I think that's the most intuitive way to do this, because oftentimes we calculate the market price, and even if you do it in some other way, I would still double check it by re-entering it and calculating the market price. So that would basically be done by taking the present value of the interest, which is an annuity calculation, present value of the par value, which would be at maturity. That's going to be a present value of 1. I'm going to do this quickly. We've done a lot of these in the past. If you want to look at the present value calculations in more detail, take a look at a prior section. If you want to look at the bonds, calculating them in different ways in more detail, including tables and formulas, look at some of our prior presentations where we focus in on that in more detail. This is going to be a negative present value, shift 9. The rate then is going to be the 10%, and we're going to make up the rate. Let me do this real quick. The rate is what we do not know, so I'm going to make it up at 10%, and then we will adjust it. What we do know is the end result, which is going to be the market price, market price, market price, and that's going to be the 870. So we're going to calculate it using the 10%. We're not going to get to 870. Then we'll use GoalSeek, we'll use trial and error, or we'll use Excel computer brute force to tell us what the rate should be. So let's do this calculation. Negative present value, shift 9, rate at the 10% that we made up, comma, number of periods is going to be 10 periods to the maturity, comma, and then the payments for our annuity payments are going to be the $100 per year, closing that up, and there it is. Let's do the present value of the end or the par value, the 1,000 face amount, present value, shift 9, rate 10%, comma, number of periods, once again being 10, comma, comma, because this is not an annuity, but present value of 1, future value being the face amount, that being the 1,000, underlining that by going to the font group and underline and summing it up equals the SUM, shift 9, and we have the $1,000. Now, what we want to do, it should be 870. So we're looking for the 870. So I could change this cell until we get to the 870, making it like 10.5 or something like that. until we get there. We're going to use Excel to do that, the goal seek function. Go into the data tab up top, go into the forecast section, go into the what if analysis, and we will seek the goal with goal seek. That's what we use to seek goals around here, is goal seek. So we're going to set this cell. We want to make that cell B. Got to make that cell B. We're going to hard code the number 870 by changing this interest rate. Change that interest rate, Excel, please. Would you change that interest rate? This is what we're saying to Excel. Change that interest rate to whatever it needs to be to make that cell, the 970, what it should be based on what we already know, which is going to be the 870. Okay, Excel does it for us just like that. Just like that. Okay. Just like what? Just like that. Can't you see it? That thing. Just like that. It does it. Just like that. Okay, now we're going to have the rate. We could do this with the rate calculation too, equals the rate. The rate and shift 9. This is the number of periods being 10, comma, the payment needs to be negative. So I'm going to say negative payment 100, comma, and then the present value is the 870, comma, future value needs to be negative. That's at the maturity, the 1000, comma, and then the end of the period, the 0. And there it is, closing that up and enter. So there we have it again. Let's calculate it a couple more times with our formula. This is kind of the new thing, the approximation on the formula. We have our calculation down below. We'll alter this one a little bit first, and then we'll do this calculation. The alteration is a little bit closer. So I'm going to build this out in a table up top. We'll do this a little bit more quickly because this is the second time we've done it. We're going to take the annual interest payment, which is going to be the 100. I'm going to put that in column M. That's going to be C, the coupon or interest payment. Then we're going to take the par value. We're looking now at the F minus P. I'm going to bring that into the inside. That's going to be the 1,000. P is going to be the market price. So I'll pick up the market price. And that's going to be equal to the 870, which I'll just pick up right there. Underline that by going to the Home tab, Font Group, Underline. And that's going to give us a subtote. I'll just put that on the outside. The 1,000 minus the 870. Then we got the maturity or years in maturity. Years to maturity is going to be equal to, what did we say that was? What are the years to maturity? 10. 10 matures in 10 years. Underline that. We're going to underline that. So that's going to be the number of years. That's going to be this component now. Once we basically divide that out. So we're going to bring that to the outside. This is going to be then the 130 divided by the 10. That's going to give us our 13. And then we can add this up, font group and underline. And this is going to be the numerator. I had to pause it there because I don't know how to spell it. But there we go. It's going to be the 100 divided by 13. Actually, it's going to be 100 plus 13. Plus, that's a plus sign. Summing this up. 13 plus 100, 113. Now we're going to adjust the denominator a little bit here. This is where the alteration is on the formula. We're on the denominator. We're still going to take the face amount and the price, but we're going to multiply it 60-40 instead of dividing by 2. So we're going to be picking up the market price. I'll take that up top, and then the next one's going to be the market price and the par value. The par value. Actually, hold on. Market price. And that's going to be equal to the 870 multiplying times 0.6. This is the new item. Number group, and we're going to add a couple decimals there. Let's underline it, font group and underline, bringing this into the outer column. This being the 870 times 0.6. And then we will pick up now we want the par value. The par value at the 1,000. The 1,000, let's pick it up top here, and that's times 0.4. And so we're going to say number, add a couple decimals, and underline font group and underline, bringing that to the outside. This is going to be 1,000 times the 0.4. Underline that, font group and underline. Then we'll add that up in the outer column equals the SUM, and add that up. That's going to be the denominator. The denominator. And then we're going to go to the home group, font and underline, and that's going to be our approximate yield to maturity. Approximate yield to maturity, which will be equal to the 113 divided by the 299, making that a percent number group percentify, couple decimals. We're at the 12.26, which is fairly close. You can see it is an approximate. We'll do the same calculation. Now the denominator, we'll do this one, f plus p divided by 2. So this is the other alteration that we want to take a look at really quickly, just so you can see these a few different ways. You might see this formula a few different ways. So the numerator, let's just do the same thing. I'll do this quickly. We got the annual interest payment. I'm going to bring that on out to this cell, S. That's going to be the 100. Then we'll pick up the par value, which is going to be the 1,000. The market price, which is going to be the 870. Then we're going to pick up then the subtraction, 1,000 minus the 870. And then we will have the maturity in years, which was 10. Underlining that by going to the Home tab, Font Group, and Underline. And then we'll divide that out. This equals the 130 divided by 10 to give us then the numerator, the num, which is going to be equal to the 100 plus the 13. 100 plus the 13. So then we have the new stuff happening here, which is the denom, which is going to be the market price plus the par value divided by 2. So now I'm going to do the new stuff. This is where the new thing happens, the market price, and then the par value. I'm going to put that over here in this column, market price, and the par value. Hold on, that's backwards. Market price is going to be the 870, and the par value, the 1,000. Underlining that, Font Group and Underline equals the SUM. And there we have that, and we're going to divide it by 2. And pull that to the outside, the 1870 divided by 2. Underline this, underline. This is going to be the denominator, let's call it. The denominator. And that will once again give us the approximate yield to maturity. I find many accounting students and finance students have a problem with the concept of yield to maturity. So this is another way you can calculate. That's why we put so much time here on calculating it multiple different ways. This is going to be equal to the 113 divided by the 935. Let's make that a percent. Number group, percentifying it, add a couple decimals. So there we have that. All right, now let's do B here. So I'm going to go all the way back to the left, and we'll do this again for B so we can do our comparisons. I didn't make this one a percent. Let's make that a percent. Home tab, numbers, making that a percent. You'll notice here we have the 11.49 versus the 12.33. Let's do it for B now, scrolling down. And so the coupon rate will simply be the annual interest payment, which is going to be $80. And then we'll have that, and then the par value. Par value is going to be the $1,000. Comparing that will give us the coupon rate, which is the 80 over the 1,000. Underlining the 1,000, Font Group and Underline, and percentifying this item. So there we have that, 8%. Then we have the current yield, which is our quick calculation. That's going to be the annual interest payment, which is going to be the 80. So that's going to be the 80. We're going to compare that then to the price, the market price, which is going to be the 800. Underlining that by going to the Font Group and Underline, that's going to be our current yield, which will be equal to 80 divided by 800. And then we'll go to the number group, make it a percent, add a couple decimals, so we're looking 10%. Now, if you look at these two, we got the 11% is the higher one with this quick calculation. And so you would think the 11% would be better than the 10% based on that calculation. And so now we'll do the more dependable one, which is typically the yield to maturity, the one where, the finance students have trouble with the concept of yield to maturity. So we'll do that calculation a couple different ways, and we'll put some focus in on it. So we're going to do it this way first. We're going to do our goal seek method, pretending we know the rate at 10%, do our normal calculation for the market price, which will typically be the present value of the interest and the present value of the maturity value, the 1,000. So we'll do this quickly once again because we've seen these before. But so if you want to see them more slowly, and then take a look at the prior section where we focus in on this calculation in different ways, tables, and also with tables and with mathematical formulas. Present value, shift 9. The rate is going to be this assumed rate of the 10%, comma, number of periods is going to be 4 this time, comma, and then the payment, which is going to be 80. 80 on the payment. Closing that up. Now we'll do the present value of 1 equals the present value, shift 9. The rate is going to be that assumed 10%, comma, number of periods is now 4 once again, comma, comma, because it's not an annuity, but present value of 1, future value being that $1,000. Summing it up equals the SUM, shift 9, adding it up, putting the underline here, font group and underline, and there we have it. Now we know what that should be. It should be 800. We want to change this interest rate there to be whatever it needs to be to make that 800. We could do that manually by changing it to like 12% and so on, or we can use the goal seek feature. So let's goal seek it by going to the data up top, forecast, what if, analysis. Let's do an analysis about what ifs and then seek the goal. What is the goal which you seek? We seek the goal to set this cell to be equal to $800 by changing this cell. So we're saying, hey, Excel, would you please make that 12%, whatever it needs to be to get that market price to what I know it should be, which is the $800 market price over here. And so we're going to say, okay, Excel just does it like the snap of the fingers. That's how fast it is, within a finger snap. So now we could also do it with the rate function down here equals the rate, shift 9. The number of periods is going to be 4, comma, the payment has to be negative, payment of the 80, comma, present value is the 800 market price, comma, future value is negative at the 1,000, comma, and you're going to do it end of period with the 0, indicating that. Closing it up, we have calculated it again. That too, pretty much, that's a couple finger snaps. I probably could have snapped my finger like 5 times by the time that was done. But the bottom line is, here's the line on the bottom, also known as the bottom line. We get to the 15.05, which is higher than the 12.33, which is kind of a more reliable calculation because you'll recall that the current yield, we had the first one was higher up here than the 10%. So we have a bit of a difference. Why would that be? Well, you can see here one reason is that this maturity date, obviously, if you just compare the interest to the price, the 1,000 compared to the price, this one, the 100 compared to the price versus the 80 compared to the price, that's our first calculation, the 10% and the 11. But this one is going to be due in 4 years. So when you look at the time value of money, you're closer with that 1,000, and this one's going to be a ways out, 10 years out. So that means that 1,000 payment you're going to get at the end is a further out into the future. So between the two calculations, of course, the one that takes into the longer term perspective is probably the one that would be more accurate over the long run. If you're looking at just what you can get return quickly, then the current yield might be the one to look at. Let's do it with this calculation again, just so we can recalculate it, doing the approximate calculation, get into those numbers again, because once again, as we know, a lot of students in finance have trouble with the concept of yield to maturity. So we'll concentrate it on estimating it a couple more times. So we'll then go to this calculation. Well, this is one we're gonna alter the numerator a little bit. So this is going to be the annual interest payment, which will be equal to the $80, and then the par value, which is going to be equal to the 1,000. Market price is going to be equal to the $800. And let's put an underline there, home tab, font group, and underline. That'll give us our subtotal on the right, which I'm going to say 1,000 minus the $800. Then we're going to have the matures in years, or years to maturity, which is going to be equal to 4 this time, 4. Underlining that, font group and underline, and then that'll give us our subtote outside here, and we'll say this is going to be equal to the 200 divided by 4, or 50. Let's put an underline there. That's going to be an underline, and that's going to give us our numerator. Let's put it up here so I get the spelling right. If I spelled it up there right. I'm not even sure I did, but whatever. You know what I mean. That's the numerator. That's the top number. So this is going to be then the 80 plus the 50. So for the 130. And then we'll do the denominator, which is our slight alteration. So we'll do this a couple different ways. So we're going to say the market price will be equal to the 800. We're going to multiply that times 0.6 and go to the font group and underline numbers, add a couple decimals, multiply that out. That's going to be equal to the 800 times the 0.6. And then we're going to pick up the par value, which is going to be equal to the 1,000. Multiply that times 0.4, adding a decimal, font group, and decimals. And then font underline. Actually, the number group was the decimal, font underline. And this will be the 1,000 times the 40%. Put the underline there. That's not the one I want. This is the underline. And then we'll add those up with the trusty SUM function, otherwise known as the sum. That's going to be the denominator. And that's then the end result is going to be the approximate yield to maturity, which will be equal to the 130 divided by the 880, making that a percent, numbers percentifying it, adding a couple decimals. You can see it's not, it's an estimate. It's an estimate there. Let's do it one more time using the second method, where we're going to take the f plus p divided by 2 on the denominator. So we'll start off with the same calculation. I'll make this a little bit smaller. I'm going to do this super fast. Not like super fast, but faster. Mid-fast. Pretty fast. So we're going to take the par value. This is going to be the same num calculations. That's why I'm doing it faster, because we've seen it a few times, and this is the same stuff on top. And then I'll slow down when we get to the new stuff. So this is going to be underline, font group, and underline. Subtracting that out, 1,000 minus the 800. It matures in number of years, 4 years to the maturity. Underlining that, font group, and underline. We're going to then take the 200 divided by 4, giving us the 50. Underlining that, font group, and underline. That's going to give us the num, otherwise known as the numerator. And sum that up equals the SUM. The new stuff happens on the denom, or denominator, which is going to be equal to the market price plus the par value divided by 2. Market price plus the par. Market plus par over 2 equals the SUM. Adding those up. Underline, font group, underline. We're going to divide that by 2, bringing that to the outside. That's going to then be the 1800 over divided by 2. Underlining the 2 here, putting a line underneath the 2, in other words. And underlining the 900. This is going to be the denom, or 8 or. And then we have the approximate yield to maturity, which is going to be equal to the 130 divided by the 900. Making that a percent, number group percentify, and then we'll add a couple decimals. So 14.44, 14.77 versus the 15.05, and the main point here being that the current yield, which is something that many finance students, get pretty good at, tells us some information, but it doesn't give us the full wealth of knowledge as the concept of yield to maturity, which is probably the more what we really want to do here. And that's the 15 versus the 12 calculation, and then the approximations on the right.